Welcome to Summarize Science, where we explore the most intriguing mysteries of the cosmos. Today, we are looking at a new study using the Euclid Space Telescope to find scaled-up versions of a strange phenomenon called little red dots. These are unique types of galaxies found in the very early universe, over 10 billion years ago. While the James Webb Space Telescope first discovered these faint red dots, Euclid is designed to look at much larger areas of the sky. This allows astronomers to find the rarest and brightest versions of these galaxies that smaller surveys might miss. The researchers focused on a specific patch of the sky known as the cosmos field to hunt for these elusive targets. They were looking for objects with a V-shaped spectral energy distribution, which is a fancy way of saying they have a very specific color pattern. In this pattern, the galaxy looks very blue at certain light wavelengths, but turns sharply red at others. This V-shape suggests a mix of hot young stars and a significant amount of cosmic dust or even a growing black hole. The team used Euclid's infrared images combined with data from the Spitzer Space Telescope to measure these slopes. By looking for this specific shape, they could separate these rare dots from more common, standard galaxies. This page shows examples of these V-shaped graphs, which act like a fingerprint for these mysterious cosmic objects. Out of hundreds of potential sources, the researchers identified 16 robust candidates that are particularly compact. One of the most shocking findings is just how massive these 16 galaxies are compared to the ones found by James Webb. They are significantly heavier, with stellar masses reaching up to 10 billion times the mass of our Sun. Furthermore, half of these galaxies appear to be incredibly old, almost as old as the universe was at the time we are seeing them. This suggests that some galaxies were able to grow and mature much faster than previously thought possible. The study also looked at how common these galaxies are compared to other objects like quasars. Quasars are some of the brightest objects in the universe, powered by giant black holes. The data shows that these scaled-up red dots are almost as common as standard quasars at these high brightness levels. This implies that they might represent a transitional phase where a galaxy is turning into a bright, active nucleus. The list on this page details the specific coordinates and properties of the final 16 candidates identified. The researchers also checked to see if these objects were already known to be active black holes. Interestingly, most of them do not show up in traditional X-ray or radio catalogs of black holes. This means these red dots are a distinct population that might be hiding their activity behind thick clouds of dust. It highlights why Euclid's specific way of looking at the sky is so important for finding things other telescopes might overlook. To recap, Euclid has successfully found a population of massive, compact, V-shaped galaxies that serve as the big brothers to James Webb's discoveries. These objects are surprisingly old and massive for their time, challenging our cosmic timelines. They likely provide a bridge between normal dusty galaxies and the most powerful black holes in the universe. The next step for the scientific community will be using spectroscopy to look inside these dots and see what is truly powering them. Understanding these objects will help us rewrite the history of how the first giant structures in our universe were built.